Hello, everyone, and welcome. And it looks like my audio levels were correct right off the bat. This will never, ever happen again. I saw some folks out there. Hi, Impy the Painter. I saw some folks out there asking exactly what is this? Well, I am a scientist and a programmer, and I am in the process of starting up some software called processing. And I am using it to explain the science while animating the science behind, yes, there are fish behind me, the science behind how one gets a planet snuggled up right next to a star, how that looks, and then how you destroy that world with that star. So yes, we are going to be doing basically different animation stuff and discussing science. And I do have 2 aquariums in here indeed. So there's the fish tank behind me, and then up there is a turtle swimming around. I had a spare fish tank that had just like one lone beta in it when a friend found a turtle. And they're like, this turtle is now yours, and it is now mine, and it is called Picasso because it lacks the grace of a Ninja Turtle. So now you know more about me than necessarily you needed to. So the software that I'm going to use for destruction of planets is, like I said, it's called processing. It's really a framework that is built to allow easy visualization and animation and drawing with Java. It has a lot of really useful libraries built in, and rather than just talking about it, let me go ahead and show it to you. So here is processing, and I really need to design a screen background so that I can see right off the bat exactly how to line things up on my screen for sharing. Okay, so here's my code. It starts out kind of boring, but it starts out with information related to this real universe star that I'm modeling. It is a star by the name of Kelt 9, and the planet is B. So we have a hot late B-type star. This means it's kind of blue, which you will see in my animation. And it has a planet going around it. The green stick is just being used for perspective. The green stick always points at the star. As it goes round and around and around, this extraordinarily hot star is heating that planet up to temperatures we normally only see with stars. So where we left off last week is the next thing that I had that I needed to do was start figuring out some of the scaling factors involved. We currently have a planet going round and round and round that doesn't change in size, and its rate doesn't appear to change. So the first thing I wanted to get a handle on was that observed size. So I'm going to calculate this in a spreadsheet. So I'm just pulling over my spreadsheet. Here we go. I'm going to rearrange my screen, it looks like. I'm trying to figure out how to fit everything on that I want to fit. So here I'm more worried about my spreadsheet, so I'll get my planet down at the bottom, and I'll get my spreadsheet up above it. So we should still, yep, there's the planet, back and forth. And so I have a planet that is going round and round a star, and I want to see what details I have. Here we go. So right now I'm not totally to scale. These radius, so let's get all of the information that we know into this spreadsheet. We can start working on the scales a little bit better. Now, right now, I have trying to figure out how to fit all of this still. Aha. Apparently I got a PhD so I can play Tetris with Windows. There we go. So my factors for my star. The star is, here we have, this is going to be in units of solar. This is going to be in units of Jupiter. This is going to be in units of kilometers. We shall do all the unit changes. So Paranor, one of the things, I got really angry at a horse and in turn ended up shouting at a trainer. I ride horses badly. And what I ran into was I was trying to convince a horse to do something that seemed like it should be simple, and the horse was just like noping me hard. And my trainer, who did not yet know what I do for a living, shouted at me, "It's not rocket science," to which I responded, "No, rocket science is easier." And indeed, rocket science is easier than many things. And this is just one of those factors that gets forgotten. I don't need to repeat those. I'm just going to keep rearranging things. So for my star, I have a radius. For my planet, I have a radius and I have an orbit radius. And I'm going to try and convert everything into kilometers. Now, to do this, I need to do some basic googly math. And what I mean by googly math is I can do things like 2.362. So let's put that in this bar. 2.362 solar radius in kilometers. And I think Google can handle that. No, not quite. Okay, so it tells me how big a solar radius is, though. So I'm looking at this number of kilometers. So coming back to my spreadsheet, I can say that this is equal to, I wrote that number in the wrong column, times that number, let's put this 2.362 in the correct place. So now I have the size of the star in kilometers. Now I have the planet's radius in Jupiter radii. So this is 1.891. So now I need to convert this. And if you guys have any questions, just at me. And I can catch that in my peripheral vision. I'm sorry, Paranor. You were working so hard to try and mod me in an organized way. And it keeps making it hard on you. Jupiter radius in kilometers. Okay, so that number it knows. So now I'm just converting the planet size into kilometers. Now the next thing I need to convert is the orbital radius. So the orbital radius I have is in astronomical units, which is the distance between the Earth and the Sun. Now this one, I really should be able to just convert. So Let's try. Stop, what are you doing? 0.3562 AU in kilometers. There we go. Scott Manley can do some truly amazing rants. It's a gift. I do not have that gift. Now, in our particular system, I want to set the my planets. I want to first of all get all of these to have the exact same number of decimal places, because that's currently messing with my brain. And Eddie is once again barking at the neighbor's children. I don't care about how many meters, so let's just go with that. I'm going to use my stellar radius as 1. So with a stellar radius set to 1, or star radius set to 1, I'm going to figure out the planet size in star radii. And that gives me the 0.08 that we've used before. Now the next thing I want to figure out is what is the size of my orbit in terms of stellar radius. So this is going to be equal to this divided by this, and that will tell me how badly drawn my current graphic is. So I start to see here, there's a few things I don't have quite right, namely how far away from the star this planet is. Now, part of the reason I drew it the way I did is this is like one of the closest planets to a star that we've seen for this big of a planet. So in my head, it was like, oh, it must be super close. Well, I exaggerated it a lot. So I'm going to work on trying, as one of the first things I do, to get this looking to scale, because I can actually do this one to scale. Now, the other thing that I'm going to need to do is figure out, as the planet moves back and forth, how does it change in size? Now, in order to do all of that, I have to figure out just how many angular degrees I'm going to have this entire system filling up. Now, I'm sitting here on a pretty big monitor, and I think I'm going to start by saying that my planet is going to be 1 degree across in my vision. If it's 1 degree across in my vision, let's see if, so this is the row of 1 equals star, r star. And this column is 1 degree equals d star. So the diameter, no, I'll do it as radius of the star, is r star. So that makes the star itself 2 degrees across. So in this particular system, the radius of the star is 1 degree. The radius of the planet is going to be 0.080 times the 60 minutes that there are in a degree. So this is 4.8 minutes across. This is actually a pretty sizable object. You could see this relatively well with your eyes. If it was in the sky, you'd see it kind of as a disc. It's not huge, but it's pretty awesome. And now the orbit is going to be huge. So this is going to be, the radius of the orbit is 32.4 degrees. So this is going to end up taking up the entire width of my monitor when I'm done. And I'm on a 44-inch monitor. but it'll be to scale, and that's kind of awesome. So now the trick comes in figuring out, as the distance to the planet changes, how do I see the size of the planet changing? I'm trying to figure out how to explain to do this in a sensible way. So what I have is the size of the object over size of circle, that size at that distance is equal to the angular size over 360 degrees. Now, we're working in relative sizes. My husband managed to find the granola bars I want. Pardon the beeping in the background. There was a granola bar mission that was occurring in the background. So what I want to figure out is how to get these into a sensible scale. I know the angular size for each of these objects. And I just need to get the proportions right, get the ratios right, essentially. Trying to think about how to do this. The reason that I'm pausing is I'm trying to figure out what scale to do everything at. So I should probably start by figuring out what is the theoretical size of the circle that I'm looking at. This is all being done in crazy units right now. Doing things in crazy units is sometimes okay. So using this particular equation, let me try and make all this spacing a little bit more sensible. So I have size over size of circle, and then angular size over 360 degrees. These are two equalities that we're dealing with. Oh. Turns out this software doesn't like it when you try and put an equals in a box by itself. Now, we are going to for starters, figure out where these things would have to be to appear the way they do, and we're going to figure this out in everything in terms of stellar radius. So if I have an angular size of 1 for my star over 360 degrees for the entire circle, and I have, for the size of the object in stellar radius, this is equal to 1, like I said, we're doing everything in stellar radiuses. That means this is 360 stellar radii across. I did this. Turns out if you do it this way, everything suddenly becomes blissfully easy. Okay. Going to stop typing now because everything is blissfully easy if I imagine it that way. So here, what I'm going to do is the 360 is equal to the angular size, physical size. Now I'm going to change the distance. That's where it gets tricky. So my star has an orbit of 32.4. So my planet has an orbital size of 32.4. So it starts out initially with the planet having a radius of 4.8 what? That doesn't make sense. Something, oh, that's in minutes. Ignore this column. This column is, I'll just add units. I don't math out loud very coherently. Sorry about that. This is in degrees. This is in degrees. Okay. So for my planet, its initial angular size is equal to 4.8 arc minutes times 60. So this is its initial angular size. But we're going to move it. And when we move it, it changes. So its initial physical size, I didn't math something right. This is 0.08 is what this is. So it starts out with a physical size of 0.08. Yes, 0.08 stellar radii, and it is on a circle that is 360 stellar radii around. Now what I want to do is I want to move the star, and when I move the star, it's going to have a new angular size, and that's what I want to figure out. Because the angular size is how we perceive it. So its new distance is going to be the size of this circle. I wish I had my iPad charged up. I don't. So this 360 size of the circle, the circumference of a circle is circumference equals 2 pi radius of the circle. Now I'm going to change my radius a little bit, so I need to know what is the radius of this circle. So the original radius of this circle is 360 divided by 2 divided by pi. So that's my initial radius of the circle. Now what I'm going to do is move the planet to be straight in front of the star. So I'm going to bring the planet closer, and that's going to make the planet appear to be bigger. So when I move the planet closer, the circle that it appears to be on is going to be a different size. In this case, it's going to be that 2 times pi times a new radius. My new radius is my old radius minus the size of the orbit. So my planet is going to appear to get significantly bigger. And the new angular size is going to be equal to this divided by this, doing cross multiplication, times this. And I appear to have, okay, no, it's the number of units it's showing that's wonky. Let me force it to have a normal number of units. So it's going to grow in size by more than a factor of 2. So this is what happens when the planet gets closer. Now as the what? Why do you need a 30 centimeter telescope, Fenmil? That is an excellent size, but why that specific size? I'm observing from a distance of 57.3 stellar radii. Thank you for whatever just happened, and I wonder why it didn't appear on the screen. That is so weird. Something occurred. Something occurred that had... Thank you, XYZABC, for the follow. I'm going to give my alert box a kick to get it working a little bit better. Copy. And then next time someone gives us a follow, hopefully we'll see the cool animation. The radius of the orbit is it's 32.4 stellar radii. Okay, and now I'm going to test my alert box by pretending to follow. Okay, it's now working. It's just in a stupid place, which is a fully fixable thing. Okay, alerts shall now dominate the screen a little bit better. Okay, so this is what happens when the planet is closer. Now the next thing I want to figure out is what happens when we move the planet further away. I really should have fought this to have more rational decimal places from the beginning. So I'm going to just copy all of this because I know that all I need to do is change a sign. At least I thought that's all I needed to do. Oh, it has a reference to the wrong cell. So in this case, I want to add the radius of the orbit in. Two pi times also another reference that's wrong, plus that. So now I see my planet is, when it's furthest away, 0.051 is what it appears. So my size has to increase as it gets closer, decrease as it gets further away. So the overall trend is going to be planet closer, middle, furthest, and the middle distance, it's going to have this 0.08 size. Now it's going to have to grow by, so this is an offset of 0. Then to get where it needs to go, it's going to have an offset of this minus this to get to be that larger size. And then as it shrinks further away, it's okay, Noel. Sorry about that. So when it's furthest away, it's going to have a size of this minus this is how much smaller it's going to appear. This is a non-linear relationship. I thought it was a linear relationship. I'm a bit confused that it's not linear. Why is this not linear? This is me trying to figure out if I mathed something wrong. Just for sanity, I'm going to work all of these together. So here's this one is, that's distance, that cell minus that cell. Now I should be able to reconstruct my middle value. Sorry for all the maths. You now understand what goes into just trying to figure out how to make the scale on something look correct. So here, I am changing that distance. Okay, so I got that number back. And now I'm adding that distance. Okay, I don't know why it's not linear. I'm not going to figure it out. I was up very late last night fighting to the death with a server. It turned out I was actually fighting to the sleep with a server because I was quite tired. And I fell asleep before I was done fixing it. Yes, the planet's radius is in stellar radii. That is completely correct, Noel. All right, so I need to go from an offset amount of, I need to add to get to that size. Then I'm at 0. And now as I keep getting further and further away, I need to subtract more. So this is actually a negative number. So what I need to do is adjust the number of decimal points again because it's determined to keep changing my number of decimal points. And this is how the size of my planet is going to change as it gets closer and then gets further away. And the reason this isn't linear is because the percent of the difference isn't changing. It's more complicated. It's that constant value where it starts out offset and I'm moving about that offset that causes this to be a not entirely linear relationship. So what I want is when my planet is dead center in front here, it needs to grow in size by this amount. So what I'm going to do is find in my code where I'm drawing my planets. So you can see here, I'm drawing star, stick, planet. I'm drawing planet, stick, star. I need to now look in here at the radius. And currently, I'm setting the radius of the planet diameter. Currently I'm setting the diameter of the planet somewhere and I'm trying to figure out where I'm setting it. There it is. So here's where I start. Now I want to offset that planet diameter by a set amount. So I start with it at the 0 value. I then, as the planet for the first 100 cells moves right, I want my planet diameter. I'm going to put this into a percent change. The percent of this is this, divided by this. So I'm looking for a 30% growth. So plant diameter. Thank you so much. Why did the animation not show? Thank you so much for doing something that didn't alert on my screen for reasons that are completely unknown. Thank you for the follow. Where is Goose? Thank you for the follow. Okay. I'm going to create another value that's just going to be int planet scale. So this is just going to be a scaling factor. I'm going to set the scaling factor in this loop. So before I draw the planet, I'm going to figure out my planet offset. Let me make sure I name those the same way. Nope, I said scale. Planet scale is going to be a cosine function. No, it's going to be a sine function because it's 0 on the far left, 0. Thank you, Keeper, for the 1 bit. Okay, now I've really got to figure out why my alert box is being so obstinate. Dear alert box, why are you doing this to me? Oh, alert box. Let's try this one more time with a test. Now it works. Okay, so we now have a functional alert box. Thank you, Canada Kim. You guys are awesome. No, Keeper of Maps, you didn't, but Canada got her bits worth out of the alert box. Thank you, Kim. My planet is no longer... There it is. Sorry. I was like, my planet disappeared. Where's my planet? Okay. I want to scale my planet. So to scale my planet, this is going to be a sine function because it starts at no change and it goes to having a change. The total amount of change that I want it to have is I want it to go up to 1.304. So this is going to be how much I multiply the radius by. And it's going to be sine of 0 over 100 because that's my number of steps. But I meant to say steps. There we go. Step over 100 times 2 pi. I think this will work. I think it will work, but only if I convert step into a float. Now, what that means is down here where I'm drawing my planet, so I'm drawing a planet, I need to scale the diameter by my planet scale. Okay, let's see if I actually did something worth doing. I failed somewhere. Why do you think I'm missing a parenthesis? I see all my parentheses. Sine. Did I forget it somewhere else? The steps are in a parenthesis. Sine is a parenthesis. Why are you being sad at me? You really think? So there's one left, one right, one right. Yes, I can. Let's move this up here. I don't know what it's being shouty about. That's awesome to hear. So yeah, Uzi Monkey, that's how I normally do it. 2 pi might be my mistake. You're right. That may be where it's being shouty. No, that wasn't. the issue. So that it agrees with me. Oh, it's 2 pi. That would be the problem. Mismatch float does not match type int. Okay, so now I can do that. And then I have to... Oh, why did I make planet scale an int? That was silly of me. It is a float. So it seems to no longer be shouting. Are you getting bigger? It is not getting bigger the way it should. That did not go as planned, but it did something. Okay, let's see what I did. So I drew a single ellipse. Oh, I didn't scale the rest of the things that it's drawing. Let's scale all the things. All of the things. Okay. Times planet scale times planet scale. Let's try that. I am scaling half of my planet apparently. And it's scaling at entirely the wrong rate. Okay, so this, instead of being 2 pi, should only be pi. I did a full circle. I want it to go from 0 to 1 to 0. So that's 180, which is only pi. And I'm apparently only doing it on part of the orbit. What did I miss? Okay, the chat is just being amusing, and I have half of a planet. Okay, it's getting bigger. It's getting smaller. Oh man, I want it to go from 1 to 130. How do I do this? So I want to add a value. I know what I need to do. I know exactly what I need to do. At some point, I'm going to need to add one more variable, because what I'm doing right now is no, that's not how I fix this. I want to go from 1 to 1.3 and back down. So what I need to do is, I'm looking for the loop where I'm calling all of this. So there's my 30% increase I'm going to do. And in order to make that work, I'm going to add it to the existing radius instead of multiplying the existing radius, or diameter, as the case may be. So I'm adding the onset on, and by doing it this way, it won't go down to 0 in the middle. I was making it more complicated than it needed to be. Pardon me while I misspell all my variables, all of my variables. And then here is the other place that I do this. There. Let's try that. Grow, 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 grow. Keep growing. Stop growing. Shrink, 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 shrink. Okay, and now it goes behind. So we got one side. Paranor, are you reading my Twitter? I was missing your questions. I'm now scrolling backwards. What values do you need from me, Noel? I see your question. Yeah, I was just very, very focused. So what I need to do is I now have this like crazy equation that I'm carrying around. So what I'm going to do is I'm going to have a planet diameter that is like my 0 diameter. This is the unscaled. So I'm finding where I set that initially. I believe there it is. So my plain Jane size of a planet is that value. I can exaggerate it. Let me one step at a time. Yeah, Uzi, that's exactly what I was doing, was extracting it. I just needed one more variable before I did that. So what I'm going to do is I have my scale that is set, and then I'm going to set planet diameter at any given moment is going to be equal to the planet diameter 0th size times 1 plus planet scale. So what I essentially did was algebra. If you look down at the craziness that I kept doing down here, I have planet diameter times planet diameter plus planet scale. This, if you factor out the planet diameter, is just planet diameter times 1 plus the planet scale. So I just pulled it out, set it up. It's all good right there. Now that means that I can come back down here to where I inserted all of the craziness, and I can now delete all of my craziness. I wish real world craziness could be deleted so easily. So there's the first of them. There's the second of them. Then I have down here one more set. And theoretically, I didn't just break anything. And I can start my animation going again, and it will go. So Noel is asking, he says he needs to know the distance to the star from the observer and how big the star is in the frame. Okay, so the star is 57.3 stellar radius away from the observer. And then the other thing you needed to know, and how big the star is in that frame. In the frame, the star has a radius of 1 degree. Pi dynamic cannot be resolved to a variable. Oh, I meant to add a variable. I deleted a variable. Shame on me. You've got to have a typo so you know that your compiler's getting its job done. Cannot convert from float to int. That is a reasonable complaint, Let's just make everything afloat. It's afloat for you. It's a float for you. Everyone gets to be afloat. Cannot convert from float to int. Sigh. Let's try that. Did I mention I hate tightly cast languages? Okay, so that seems to be working. Grow, 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 grow. You're growing. Stop. Shrink, 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 shrink. It's shrinking. All right. So I saw a request to see if I could exaggerate this, and the answer is yes. The way I did this, it's actually super easy to scale once I find where in the code I stuck it. Right there. So here, I can just multiply this by like 5. Let's super exaggerate that. Except I want it to be a float. There's a theme. Everything needs to float today. Let's see if there's any more questions. Part of me is always afraid that it's not going to come out the other side of the star. So yeah, we have it appearing to grow and appearing to shrink. It's doing its thing. Now, since this is a non-linear relationship, it needs to get smaller as it passes behind the star, but it gets smaller by a different amount. So I'm going to add in the details for that here. And in this case, it's going to be 1 minus planet scale because I'm shrinking the bastard. Apparently, I also threaten the parenthood of variables when I am programming. Okay, so in this case, it needs to get reduced in size by... This is equal to 1 plus that divided by, oh, not using parentheses correctly. Divided by the radius. That's wrong. This is equal to this divided by this. So I need to shrink by 36%. So that's where my sign becomes important. Let's move this so that I can see the number I'm aiming for. So 36. And in theory, it should go. Grow, 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 grow. Shrinking, shrinking, shrinking. Let's see if it appears. No, that was the wrong direction. Why is it the wrong direction? So I'm going to delete the star just so that we can see what's happening. And by delete it, I mean I'm going to comment it out. Again, something you can't do in the real world. So let's see what happens. Growing. Now you should shrink as you move further away. You do not. You do not. Okay. I guess I didn't need to change the sign. I guess I wrote code that I was overthinking. Oops. That did not go as planned. That really did not go as planned. That was bad. Okay. So here I am step 100 to 200. So this is where it goes negative in my pi function. So it should go from 0 to -1 to 0 for my sine, which is why I didn't have to change. I am confused. Like behaves perfectly in the one direction. But I know it's a sine because it should go from 0 to -1 to 0. So this is my pi to 2 pi part of the circle, which is where I have a step value of 101 over 100 to 200 over 100, which is what gets me to my 2 pi. And why I'm so confused. Okay, I'm going to try some things to try and figure out what is going on. Specifically, what I'm going to try is planet diameter is equal to 100.0 times planet scale. Actually, no. Let's just, as a starting point, do times sine of float step divided by 100.0 times pi. Now, this should reduce itself down to a radius of 0 and then come back. I've been programming in Python lately and my brain's like, you don't need that semicolon. So we're growing correctly as we go to the right. Go to 0, come back, all right, so that part seems to be working. So let's do planet diameter times 1 plus all those sine functions. Let's see if that works. What? What? Oh, I got rated. Thank you, Blame Pig. Thank you, Blame Pig. I totally missed the raid. That is awesome. Thank you. Yeah, coders get totally lost in thought. It's what we do. And now I want to know if my planet shrinks correctly going on the other side. I shrank it like to a negative size. Coming back, coming back, coming back. Why didn't my planet come back? Okay. 1 plus the sine should just go to 0. Yeah, I shrank it past its a blank size. Okay, so let me go back to the 100.0 and see what happens. Thank you so much, Blame Ping, for the... which I misread like the first 40 times. Thank you so much. Oh, Heptacular Raptor, thank you for gifting Blame Ping, which is better than Blame Pig. I'm sorry for inadvertently renaming you. Okay, so it works at that size. I swear it's coming back late, but that may just be a perspective-y thing. The cosine would have it be 0 on the right and the left and biggest in the center. Cosine's what we're using on the stick size. We have another Canadian. Welcome, Canada. I blame you for growing my audience, which is an excellent thing. It makes you favored human beings. What are you giving up on, Noel? So I'm doing everything in orbital radii. So I'm assuming that the star has a size of 1 in orbital radii. So the angular size of the radius, not the diameter, the radius is 1 degree, and the size is 1 stellar radius, and it is 57.3 stellar radii away. So yeah, I'm doing everything in crazy units. Which reminds me of when I took relativity and we did everything related to C. So 100 it lets me do. And what I don't understand, since this is just a 1 plus, is sine can't exceed 1. So I should be able to do this just as easily with any size, as long as everything is a float. So let me try it at 50. I'm kind of uncomfortable with that language, Paranor. Kind of uncomfortable. Wait, what? APC seems to have been stolen and is on the loose. I'm now clicking on the story. A tank on I-95. Someone stole a tank in Virginia, which is like a highly populated part of the US. Okay, I'm going to go back to doing planets because it messes with my mind less. Okay, scaling, small, coming back. Okay, so it may just be that it's too small and angular to size to see most of the time. So let's do oh, I know what I did. I forgot to put the 0 diameter. So I was like multiplying it by itself, and that was not going as one would wish. Okay, so that's growing in front of the invisible star, shrinking. And the green stick is supposed to always be pointed towards the star, shrinking, doink. Coming back. Aha! I got it. So now I can bring my star back. And we should have a planet with correctly that's exaggerated, but we have it with varying scale that is growing and shrinking as it goes round and round and round. But Noel, I already mathed it at this size. I like my maths because they're done maths. Okay, so I'm putting back the angular size, and I'm also going to switch it so that the entire thing is to one scale, in which case the planet's orbit becomes 32 times bigger. So this is eventually going to become a very skinny, long rectangle. Okay. So we have it all working at one scale size. Yes, it's going to be 32 signs bigger. It's not green. It is smaragdine. Smaragdine? I'm not sure how to say that. It is true. And now we save. Thank you for reminding me. My IDE that I use at work auto saves, and it's a glorious thing. Okay. So I'm going to do one final thing before I call it a day. I'm going to get the radius of the orbit to be to scale, which means I need to change the size of my going back and forthy bit to be significantly larger. So I'm going to set this to, I don't know if that will work. I'm just going to make it huge first and see if it fits on my screen. Oh, I did that in the wrong axes. Okay, let me try that again in the correct axes. Okay, so actually that is 10 times bigger. That is 30 times bigger. So I'm just going to do that for good measure. I don't know what the hell just happened, but it was funny. A planet just shot off to the right. Let's try cutting this sucker in half. I'm going to have to play with things to get them all to fit. That is a very high-moving planet that's going off the edge of my screen. The moral being, my screen is only about 4,000 pixels wide. Okay. Zoom! My screen is apparently not 4,000 pixels wide. How big is my screen? Or more to the point, how much is it scaling things? Because my screen is a 4K monitor, so that should have fit. There we go. Why isn't it drawing a star anymore? I'm confused. I now have a much faster moving setup that ate my star. The orbital radii should be 32 stellar diameters. I don't think we're in the star. Fenmil, I actually had a moment of like middle class problems of I bought this 43-inch monitor and I like used all of my Amex points and it was on sale and the whole 9 yards. And then like a week later I saw a 44-inch by a slightly better manufacturing, like just a snert better, for like $70 more. And I was like, damn it, I could have gotten one more inch. So where did I set? So the sun is at width divided by 2. Oh, no, I'm no longer dealing with a square. That doesn't work. Okay. There we go. I got my star back. Zoom. Now, everything is done scaled by the solar radius. And that means what I want to do is make this, let's try making it 100 tall and then 3,200 wide. I don't think that will work yet. I now have ridiculousness. So somewhere in here, I set the radius of the orbit. So the planet's orbital radius gets set where? Pardon me while I read my code and try and figure out where I put different information. Draw planet. Planet X, planet Y. Yes, but where did I set planet X? Planet X is declared as an int. There it is. Planet X is going to be no, that's the size of the planet. I need where it gets drawn. What did I do? Because somewhere I'm varying the planet X. Okay, I'm going to give up reading my code and search my code. So planet X, equals planet X plus orbital step. So that's how I did that. So I gave it a starting position and my orbit times step is set somewhere. So that's how far it's traveling. Okay, so next week I'm going to sort out how to get the orbit scaled appropriately. Because my brain just stopped. 3.15 stellar radii in the orbital plane is the orbital radius. I got 32. We need to compare maths. Says the guy who has worked in minus 40 temps without wind chill factored in. I've done that too. And a hard drive refused to spin up. I was an astronomical observer at Michigan State University and a ski lift baggage operator. At least you're working up a sweat. That's the only thing I've got going as a compliment for that one. Yeah. Where are you? Yeah, keeper maps are about a factor of 10 apart, so I need to figure that out. Where are you, Blame Ping? I'm sorry again, I keep renaming you. Oh, Winnipeg. It's a place. I haven't been to the place. I've heard that it's a boring place, and it's where Winnebagos are named after. There's something about cold Canadian cities that generate big mosquitoes. It's true. It's true. It's what I've been told. My husband's Canadian. Oh, I didn't know Winnie the Pooh came from Winnipeg. Okay. Anyways, I'm going to drop off because my brain has stopped and I am going to raid over to another account that is getting ready to launch, and this will humor many of you who don't know what's about to happen. But I will see you on the other side in a few minutes if all goes well. So let's see.